Hi everyone, this video is on exercise 13a. So in this video, I'm going to do parts A, B, and C, and I will do some of the other parts in the next video. So this question is all about integration. So that's the reverse operation to differentiation because, and just a very brief introduction, when you want to differentiate a function, let's say f of x, when you differentiate a maybe it's better if I give you an example so you can have an idea. So let's say you have this function f of x which is x squared and you differentiate this. So you do dy by dx, or in this case f dash x. So you find the derivative which is f dash x and you get 2x, right? So that's differentiation. But in integration, you are given the derivative and you want to go back and find the main function. So that's the difference. So you integrate this function, and by the way, this is the notation which I will write later and explain that. But yeah, you go from the derivative to the main function. So that's why it's the reverse operation. So in this case, we want to integrate each of these functions. And in the first example, we have, let's say, dy by dx is equal to x to the power of 5, and we want to find its derivative. Sorry, the function. So this is a notation that we use for integration. By the way, this is the first exercise of the integration chapter, and in exercise A, they haven't formally introduced the integration notation. So you are going to use that from the next exercise, I think. But I'm just using the main notation for this exercise so you can get used to this now, because this is the thing that you will be using from now on. Right. So the integral of x to the power of 5 with, and then with respect to x. So this is just notation, this symbol and then dx. This is just part of the notation that you always write, and then the function itself here. Okay, so it's actually very simple. If you want to differentiate a polynomial like this, you just add 1 to the power and write the polynomial, and then with power plus 1. So 5 plus 1 is 6. And then also divide the polynomial by the reciprocal of the new power, which basically means divide this by 1 over 6. And then you also add a constant term here, which we are going to see this more from the next exercise. But the idea of this constant term is that if you have a function and you differentiate that, then and then if you want to go back, you just need to write this constant. So just to give you a quick example to get an idea, if you have this linear equation and then let's say y is equal to 2x plus sorry, not c, plus 5, and then you differentiate this, so you get 2, right? So now let's integrate 2. So if you integrate 2 with respect to x, you are going to get 2x, because whenever you have a number and you integrate that, you're going to get 2x, for example, if you're integrating with respect to x. So as you can see, if you integrate with the usual method, you only get 2x. You don't get the 5 here because the actual function has a plus 5 term. So that's why we also write this constant term here, just to account for that. But later on, we are going to discuss this in more detail. So for now, just remember that this is how we do this. So these are all going to make more sense in the next few exercises. So for now, it's just an introduction to the method. So for the next part, we have dy dx is equal to 10x to the power of 4. So again, we integrate the function dx. So again, write down the x and then the power plus 1, which is 5. And we also have this 10, but remember, we always divide the function by the reciprocal of the new power. So that's divided by 5, and as always, write down the constant, which is c. And then this can be simplified to 2x to the power of 5 plus c, and you can just double check this by in case you're not sure, and differentiate this. So 2x to the power of 5 differentiates to 10x to the power of 4, and then this c just differentiates to 0 because it's just a constant, and you get this. Okay, and let's do one more. So part C, we have minus x to the power minus 2. So the power is negative, but it doesn't change anything because we just integrate as usual. So the integral of minus x to the power minus 2 with respect to x. So we can write minus x and then the power plus 1. So minus 2 plus 1 is minus 1. And then divide by the reciprocal of the power. So the reciprocal of minus 1 is just minus 1. So you divide by minus 1. And also, you don't need to write this down if you want to do this in your head. Feel free to do in that way. As you get more experience, you don't need to write this down. And then also plus c. So this simplified is simply x to the power minus 1 plus c. And again, x to the power minus 1 differentiates to minus x to the power minus 2, and c differentiates to 0. Okay, that's it for this video, and thank you for watching.